Okay, so in this video, we're going to use the law of sines to calculate a course to pass a beam of an object a certain distance. You are steering 180 true at 15 knots, and you see a light 40 degrees off your port bow at 8 nautical miles. You wish to pass 3 nautical miles of beam to port. What course should you steer? Okay, so first thing we should do is maybe draw our diagram. So we're going 180, so I can draw a little line here that represents that. And then we see a light 40 degrees off our port bow. So, I'm going south. This is my port side. So I'm going to be over here 40 degrees. So there we go. And so let's say that there's our light. I'll just put it randomly there. And it is 8 nautical miles. So we know that this leg here is 8 nautical miles. Okay? Now it says we wish to pass 3 nautical miles of beam to port. Well, that means that's basically our CPA, okay, our closest point of approach. We want to be a CPA of 3 nautical miles. So, I can draw a little circle around here, and now I can figure out which side is going to be a beam to port. So again, if this pencil represents my boat here, my starboard side, my port side, I want to leave it on my port side. Therefore, I'm going to want a course to steer. Okay, assuming that there's no leeway, that's going to be just tangent. I didn't quite draw it that way, but this should be just tangent to that circle right there. Okay, so let me just fix that because that's really, anyway, yeah. Okay, great. In case there's any math professors watching right now, I got to make sure I do that. All right, anyway. Okay, great. So it's just tangent there. And we want that to be 3 nautical miles. Now look, a beam means 90 degrees to my heading. So this is going to be my heading, okay, which will also be my track, assuming there's no set or drift. And so what we're going to have is a 90-degree angle right here. It's very important that you place the 90-degree angle on the right side. It's never going to be at the light. It's always going to be opposite the light, okay? At the intersection of your course that you're steering and the CPA leg right there. Okay, great. So now, that means that we want to calculate this angle here, okay, from here to there, all right? That's theta, all right? So we actually know a little bit more information. If this is 180 and that's 40 degrees, that means that the light is bearing 180 minus 40, which is really 140. So now when I want to calculate my course to steer, okay, to pass a beam at 90 degrees, I'm going to add theta to 140. It's going to equal 140 plus theta, and that will give you the course to steer. So now I got to do that. I'm going to use the law of sines. So the law of sines, I'm going to solve for theta. So I'm going to start off here by saying sine theta, and it's the sine of this angle over the length of the leg opposite. So that is 3 nautical miles. 3 nautical miles is proportional to, is related to, is equal to. Okay, now I'm going to use, since I have sine on the top here, I got to have sine on the top of my next one. And my next known angle and leg is this angle, 90, and this leg, 8. So I'm going to go sine 90 over 8 nautical miles. Okay, great. So I'm going to solve for theta here. So I'll have sine theta equals sine 90 times 3 nautical miles over 8. Well, and then I'm going to do theta is sine to the minus 1, the inverse sine, and then that's sine of 90 times 3 over 8. Okay, great. Well, all right, so now I'm ready for my calculator. So let me find that. Hold on a second. Okay, great. Now, here's my calculator. I'll turn it on, okay? Now, the beauty of this problem is that you actually don't even need to do sine of 90 in your calculator because that's always going to be equal to 1. Let me just show you that. But there's sine 90. It's equal to 1, okay? So that makes the math a little bit simpler. So now this is going to be theta is inverse sine of 1 times 3, which is really just 3 over 8. So let's do that. Second sine of 3 divided by 8 equals, and that is 22 degrees. So theta equals 22 degrees. All right, great. So now my course to steer is going to be, over here I did this little thing, but 180, it's 40 over, that's 140. Now I'm going to be, theta is 22 degrees, that's here, okay? So it's going to be 140 plus 22. So the course to steer, assuming there's no leeway or set and drift, it's going to be 140 plus 22, and that will be 162 degrees. Now, you can also solve this using a maneuvering board, and you can also solve this using right triangle trigonometry. You can just solve this using the sine. Just sine is opposite over hypotenuse. In this case, the hypotenuse would be the distance to the light. But this law of sines is another way of doing it. And if you're looking for one method that can solve multiple different types of problems that you might find on the chart plot or the near coastal module, law of sines can, if you learn this one method, it'll solve a variety of different problems. And I'll try and put a couple of links down in the down below for how to solve it by maneuvering board and how to solve it by right triangle trigonometry. Okay, have fun with that. Bye.